Hi and welcome to my review of the Lavolta BPS-305 DC power supply. As you might have seen in my unboxing video, this is everything that's delivered to you. You got your user manual, the mains wire, some wire to connect your load, and the power supply itself. I've already read the user manual, and right on the first page it states you should never power the power supply on or off with an attached load. It might damage your device, or the power supply itself might get damaged. You should especially be careful with inductive loads like a coil or a motor, because if you power off you can cause a spike and this might damage the power supply. Besides that, there is nothing major in the user manual, but I would definitely recommend reading it to everybody who bought this power supply and wants to use it properly. Let's take a closer look at the mains wire. It is an H05 VVF, 3 strains, 3 wires, times 0.75 square millimeters square area. A good wire for this application. Looks all in all of decent quality. The 0.75 square area should be enough for this device, because this power supply puts out 30 volts at 5 amps, which is 150 watts, and if you calculate in like 50% losses, then you get a maximum of like 300 watts, and this cable should have no problems with that load. You could actually use it for quite a bit more. I think you can use this cable for up to 1300 watts, so like 1000 watts more. This is quite decent. This is very good. Let's take a closer look at the wires that are provided to attach your load. I don't know if you can see that, but there are two different types of banana plugs. This is like the old school with 4 springs. This is like a newer one with more smaller springs. I'd like to zoom in and show you up close. You can see this is the older style, and this is the newer one. But the spring is also quite loose on the plug itself. There's a lot of play in here. This might cause a bad connection with high resistance, or even a loose one. I don't think it's supposed to be this wobbly. Let's see if this works. Yeah, you can plug it in. On this side, it won't go in. Yeah, that's really not great. I also noticed the screws to fasten the cable in, they protrude out. So it's a very real possibility that they touch each other and cause a short or something like that. It's an easy way to blow a fuse or destroy your device, so that's rubbish. Let's take a look at the other end, the Alligator Clips. They are kind of difficult to engage, really uncomfortable. They kind of roll around in your fingers. You almost can't get them open. Get the isolation off. Yeah, that's why, because they have like a solder blob on here, and it really digs into your finger, and it's quite uncomfortable. Also the lever, the tab is really small. You almost have to use your fingernail. That's bad. Closer look at the soldering joint. It looks like it isn't even coated all the way. It looks like it might be a cold joint. I can see a few strains out here that are not covered in solder. Gonna take apart the other one. See what's that like. It's exactly the same. And it isn't. Also looks like a cold joint. And they're also not covered properly. The soldering joint on this Alligator Clips looks like it might be a cold one. I'm gonna try to rip it off and see if it actually is or is not. Yeah, that's ridiculous. Only like half of the blob actually coated the Alligator Clip. It's definitely a cold joint. Try this with the other one, so you have it up close. And in focus, let's hope. That was even easier. Look how small that is. Only this small bright area was actually coated. That's ridiculous. These are rubbish. Since I definitely have to do that again, I'm gonna just cut the wire and see how big it actually is. I took my calipers out and I measured the diameter, and it seems to be like 0.75 of a millimeter, and if you calculate the square footage, it's like 0.44 square millimeters, which would be enough for the maximum rating of this power supply. It's only 5 amps. The wire is thick enough, but the joints on the Alligator Clips, they are just rubbish. This one was cold. You have to do him again. There's no way around it. I have to repair this cable later on, but it's really a bit junky. I'm gonna have to replace this cable. I don't like this banana plugs. They're rubbish, and also the Alligator Clips. The solder joints were cold, and I have to redo this cable or just throw it out and use something else. This is really bad. I think it belongs in the garbage bin. I'm really happy they cheaped out on this cable instead of on the mains wire. I think this is a lot better quality than this one, and I'm happy they cheaped out on this one instead of the main cable, so yeah, they chose wisely. Let's take a closer look at the power supply itself. It has a metal casing. The base is also metal. It has rubber feet, which is good for traction and for isolation, so the vibrations from the fan or something like that won't transmit to your table or your workbench. But I'm probably gonna put some cardboard or something like that between these rubber feet and my table, because I don't trust them all that much and I think they might stain my table. There is a big handle up top. It's also quite necessary because this power supply is quite heavy. It weighs 5 kilos. It weighs so much because it uses a transformer. Maybe you can see it through these slits in here approximately, and that's why it's so heavy, and that's why it needs a handle. So it's a good thing they installed one. At the back we have the mains connector, and it also looks like there might be a fuse in here. Let me grab a screwdriver and pop that out. Yeah, there is a fuse in here. This power supply has a mains fuse. It looks like 5 amps and 250 volts. Not a big one, but it's enough for this application. There's also room for a spare one, but it's not included. But thumbs up that it actually has a fuse. Good thing. So now let's plug it in and see what it does. Before I power this power supply on, I'd like to repeat the warning from the user manual, which states never to power it on or off with an attached load. This might destroy your device. And because it's just such an easy mistake to make and has potentially catastrophic results, I used my label maker and printed myself some warning labels, which I'm gonna attach to the power supply so I know to never power it on or off with an attached load. I feel like this should have been the manufacturer's job, but yeah, what are you gonna do? Now I just need to remember. Let's power it on. You can immediately hear that it's a bit noisy. You can hear the relays clicking when it powers up, and you can also hear the fan. I'm gonna put my mic closer to it. You can definitely hear the fan. I noticed there are no markings or indicators on the knobs, so you don't know where min, where max is, and where your knob stands in relation to them. You don't also know in which direction you have to turn to increase or decrease your value, which is such a stupid mistake. There's really not that much work in making a marking. Yeah, somebody just forgot it and probably didn't use this device, or it would have been obvious immediately that you need a mark to know where the knob is and where you are on your range. Thumbs down. That's a stupid mistake. I also noticed that the travel is quite small. From min to max, it's less than a full turn. It's really sensitive. It's really difficult to adjust the value just right, like to get it like to 21 volts. Yeah, it's probably what the fine adjustment is for, but this is really sensitive. So it's really necessary that it has the fine adjustment, because you almost can't get it right. You can also hear the relays clicking as you go through the range, and I'm gonna put the mic closer to the power supply so you can hear it. First. You could hear the relays clicking at 7.5, at 15 and at 20 volts. That means that the transformer in here has 4 taps, because you have 4 ranges. And that's a good thing, because if you have 4 taps, you don't have to waste so much energy. Let's take a closer look at the banana posts. First thing I notice is that the threads go a bit rough. There's a little bit of resistance in them. And as you can see, the banana posts are made out of brass. Brass is a good material for this use because it's cheaper than copper. It still has quite a good electrical conductivity. It has a good corrosion resistance to salt, like from your fingers. Some brass alloys have also self-lubricating properties. And most important, brass is easily machinable, not like copper. The nut itself has also an insert made out of brass, which is good. Let's take a look at the other 2 posts. There is also this metal bar in here, which short circuits negative to ground, which reduces noise, but you can remove it when you use this power supply in a symmetrical power application. If you have a second power supply and you want to have like plus minus 20 volts. As you can see, the threads on the banana posts look a bit rough. That was probably caused by a badly worn tool that was used to cut them, and that's not so great. This is like a brand new screw in comparison. The edges are really sharp and quite clear, whereas on the banana post they are rounded off. This also doesn't look like a metrical thread, because this is an M6, and as you can see there's quite a bit of difference between them. I'd like to determine the thread pitch. For this I'm gonna use an old trick. It's like to cover the metal with a paper and then rub a pencil across it. Let's see if that works. Yeah, here we go, you can make out the threads. I took a measurement from the threads. I didn't use the first thread and the last one. I marked off 5 threads and measured the distance between them, which is 3.25 millimeters. That divided by 5 threads gives us a thread pitch of 0.65 millimeters, which is really strange because this is definitely not a metric thread, because a metric M6 normal thread like this bolt uses a thread pitch of 1 millimeter. There is also fine threads which use a thread pitch of 0.5 millimeters and 0.75 millimeters, and this 0.65 millimeters is quite a bit off, so you won't be able to use a M6 fine thread nut on these posts. I really don't like this custom thread, because if you lose one of these nuts you are pretty much screwed. You won't find anything in your hardware store to replace them with. And these are built in, so it's not easy to replace them. Yeah, that's really bad. I don't like it. That's a mark against it, definitely. Why not just use metric thread? It's easy. You got all the values you need. It's all worked out, it's reliable. That's really stupid. I don't like it one bit. I'd like to show you the inside of the banana post, and from the looks of it, these posts were not only drilled but also reamed, which is great because it provides a way smoother surface on the inside, which is great for a low resistance connection. This is of course an additional step in the manufacturing process, and it's great that they did that, but by the looks of it there might be a bit of dirt inside them, so it might be a good idea to clean them out before you use them. There's also a burr on the outside that I didn't get rid of. I might just knock that off with a drill bit and that's it. This is a close-up of the threads on the nuts, and as you can see they are much cleaner, much nicer than the ones on the post. So they can cut good threads. It's just probably the tool for the post was just worn and they didn't want to replace it just yet. I'm using a 8mm drill bit to clean out the burr. Afterwards it's a good idea to clean out the holes, and as you can see there is a bit of dirt inside them from the manufacturing process, but that's okay. So now cut off the burr. The plugs should slide in better. Let's put the nuts back on. The threads are a bit loose. As you can see, I'm almost completely on the post and it's still quite wobbly, as you might hear and see. So the posts are really not that great, but I think they're good enough. It will do the job. It's just don't over tighten them or you might break the threads and then you're screwed. You also have this switch to switch between low amperage mode and high amperage mode, and the difference is in low amperage mode, which is lower than 3 amps, this produces less noise than high amperage mode. If you have like a really sensitive microcontroller or something like that, and you don't need much power, you should leave it in low amperage mode, which gives you a cleaner output. The power supply is usually in the constant voltage mode, which is indicated by this green LED. And when you want to adjust the maximum current, you should dial down the voltage, but not completely to 0, like 1 or 2 volts is okay. then short circuit the outputs, and then it switches to the constant current mode, and now you can adjust your current. Like for example, you want to limit your output at 1 amps max, you adjust it to 1 ampere and then unplug it, and then you can adjust your desired voltage, like maybe 12 volts, and then you can have a maximum of 1 amp. As a load I have this heat bed, which I'm gonna try out. Let's plug the negative and positive. 2 and 3 are ground, and this is the positive. And it goes to current limiting mode. We can ramp up, and as you can see, the voltage increases accordingly. I'm in low power mode now. It doesn't go much higher. I'm gonna switch to high power mode and dial it down a bit. Power it on. 4, 5 amps, 5 volts. The heat bed is basically a 1 ohm resistor. I can actually feel heating it up. That's for the load test. I also like the different color LEDs to indicate which mode you're in. You see at a glance that you're in constant current because it's red, and green when you're in constant voltage mode. That's a good thing. Another thing I don't like about it is if you are in the constant voltage mode and you turn the dial on the current limit mode, you actually do change the value for the current limit. You have to be aware of that when working with this device. Yeah, that's another pitfall. Some facts and figures. This power supply goes from 0 to 30 volts and has an output range of 0 to 5 amps, and it has an operating range of 0 to 40 degrees ambient temperature, which is enough for most applications. That's it for part 1 of this review. I hope to see you guys back for part 2, where I will continue with the teardown. That's it. Bye.